Hi folks, and welcome to the third and final video clip on partial fractions. And in this session we're going to look at repeated linear factors in a denominator. So here's a typical example. We've got x plus 1, a linear factor squared, and another linear factor x minus 1. If this is the case, we guarantee to be able to write it as three partial fractions where two of them will involve the x plus 1 in the denominator. One of them will have the x plus 1 as a linear term, and one of them will have it as a squared term. Now it could turn out that d comes to 0, in which case it would just disappear. But you can't know that when you start doing the question, so you have to allow it to be there. Right, so what we're going to do to start with is very much like what we did in the other partial fractions. I'm going to write the numerator, and say that has to be an identity with the numerator on the other side. And if we look at what we've done to the denominator below the d, we've multiplied it by x plus 1 and by x minus 1. So we do the same to the numerator. Second one, the only thing missing, the only thing we haven't multiplied, we have to multiply by is the x minus 1. And then the third one, we need to multiply by the x plus 1 squared. So now we do what we've done before. We choose values of x that's going to make one of the brackets 0. So let's start with x equals 1. This would be minus 1 squared minus 10 times 1 minus 5. And that would be equal to, now when we put the 1 in the x minus 1 bracket, it comes to 0. So that's going to force the first two terms to 0. And we're just going to be left on the right hand side with f 1 plus 1 squared. This comes to minus 1 minus 10 minus 5, which is minus 16. 1 plus 1 is 2, square root is 4, so that's 4f. So f is minus 16 divided by 4. Answer, f equals minus 4. Now we're going to put x equal to minus 1. And I get minus 1 squared minus 10 times minus 1 minus 5. And that is equal to, well, which brackets are going to go to 0? It's the one with the d and the one with the f. So we're going to be left with e, and we'll have minus 1 in the bracket. Left hand side, minus 1 squared is 1, but there's a negative in front of that, so that's minus 1. Minus 10 times minus 1 is plus 10, and then there's minus 5. And that's equal to minus 2e. 10 minus 6 is 4. 4 is minus 2e, so e is equal to 4 divided by minus 2. So e is minus 2. Now what about the third one? We haven't found d yet. Well, what we do in this situation is we look at the coefficients of one of the three terms. We can either look at the coefficient of x squared, the coefficient of x, or the coefficient of the constant. And often it's easiest to look at the coefficient of x squared. Because this is an identity, there has to be the same number of x squareds on the left as there are on the right for all values of x. So I'm going to look at the coefficient of x squared. So how many x squareds do we have on the left? We have minus 1 of them. How many x squareds do we have on the right? Well, you can see that d is multiplied by x plus 1, x minus 1. If I multiply that out, I get x times x is x squared times d. So I've got d of them there. In the middle term involving the e, there aren't any x squareds. But on the final one, if we multiply that out, we'd end up with x times x is x squared times f. So I've actually got d plus f x squareds. But we know that f is minus 4, so minus 1 is equal to d, and plus f will be minus 4. So D is equal to minus 1 plus 4, which gives the answer D is equal to 3. And that completes that question. Let's have a look at another one. Now here the repeated linear factor is x, because we can have x, we can have x squared. But it's not very clear what the denominator actually is unless I factorize the denominator in the original term. So let me rewrite this as 5x squared minus 2x minus 1, and what we're doing here is we've taken out a common factor of x squared. Rebuild the bottom, we'd need to multiply by x minus 1. So that's the denominator. And that's going to be equal to c over x plus d over x squared plus e over x minus 1. Same again. We're going to write 5x squared minus 2x minus 1 has to be an identity. Now what are we going to have in the numerator? Because the denominator we know will be the same on both sides. What do I need to multiply the c by? Well, I need another x to get to x squared in the denominator, and I need x minus 1. D, the x squared is already there, so I just need to multiply by x minus 1. And e, I've got x minus 1, I need to multiply by x squared. Off we go again, putting in the values. X equals 0. The left hand side will become minus 1. The right hand side, the terms involving c and e will both be forced to 0, so the only one that survives is d, which would be 0 minus 1. So that gives me minus 1 is equal to minus d, so d is equal to plus 1. Now we're going to let x equal 1 to make the x minus 1 bracket 0. So what does that give us? 5 times 1 squared minus 2 times 1 minus 1 is equal to, and the c term and the d term will come to 0, and we'll just be left with the e like that. So we've got 5 minus 2 minus 1 is 2, and this is equal to e, 1e. So there's the answer for that one. E is equal to 2. And again, I'm going to look at the coefficient of x squared. I could look at the coefficient of x or the coefficient of the constant. It doesn't actually matter. So how many x squareds do I have on the left? I have 5. How many x squareds do I have on the right? Well, look at the c term. You'd have x times x if you multiplied it out times the c, so I've got c of them. The middle term doesn't involve any x squareds, and you can see I've got e of them in that final term. But I know that e is 2, so 5 is equal to c plus 2, meaning c is 5 minus 2, to give the answer c is equal to 3. Right, and that's all there is to it, and what I'm going to ask you to do now is work through the odd numbers in exercise 1e.